All right. Welcome back, everyone. Just to introduce myself real quick, my name is Mario. I'm a researcher and a postdoc at the Ruhr University in Bochum. I wrote my PhD thesis on the topic of client-side security and defense, mainly JavaScript and the DOM. I own a small penetration testing firm. We do consulting, workshops, trainings, and pen tests. I wrote some books, wrote some papers, published some tools, and sometimes I tweet, and if you want to drop me a line, then just write me a mail. My personal research focus is mainly everything that is inside lesser than and greater than. So I like to poke around with HTML, even the old variations, HTML 2.0, 3.0, and so on. I like to play with HTML5 and the upcoming HTML 5.1. I like JavaScript, I like JScript, which is fundamentally different from JavaScript. I like VBS, Visual Basic Script. Who here knows VBS, Visual Basic Script? Who here knows that IE still supports it as like a scripting language in the browser? Excellent, that's great, right? I love it. I like to play with plugins, with controls, editable rich text and specifics, scalable vector graphics, MathML, everything that is kind of XML-ish, HTML-ish, and can be displayed by a browser. What I really can't do, because my brain is too small, is binary stuff, so I can crash a software, but I can't move on from there. I'm just not capable to do so. Most of my focus is actually offensive research, injection scenarios, active file formats, parser analysis, and what really gets me going is like these old legacy things, like old features that are existing in the browsers, almost not documented anymore, but then at some point you find them, you stumble upon them, you discover that they still work, and then you can do awesome stuff with them. I really love that. I'm doing a bit of defensive research as well, XSS filters, WAFs, IDS systems, had a look at CSP, which we heard of this morning. Was once creating like a DOM-based XSS filter that didn't work, and I'm kind of right now working on a project that involves DOM policies to give us a bit more trust in the DOM and the DOM object model. Now you might ask yourself, this talk is going to be about HTML, and why another talk about HTML, and why another talk about cross-site scripting, because there have been plenty in the past. In my opinion, there's one simple reason: HTML is on its way to absolute ultimate power. So everything is going to use HTML websites, web applications, of course. Instant messengers are using HTML rendering engines. Email clients show HTML emails. The local documentation for your favorite tools and test cases is all written in HTML. We have router interfaces, coffee machine UIs that are written in HTML or displaying HTML. We have medical devices, according to this source, that are actually capable of being maintained via a web backend, like a pacemaker that has like an HTML backend for updatability. I hope the address resolves. There we go, Spectrum medical device connectivity, blah, 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 blah. Totally flexible and field upgradable via web interface. Like, what the hell? But anyway, so HTML is around. We see HTML working on operating systems. And we can basically say that the HTML plus the DOM plus JavaScript is like a very, very powerful toolkit, and we're going to see it in the future a lot. Just some days ago, I saw a presentation from the W3C where the inventor of HTTP, Dave Raggett, was actually announcing that they plan to bring HTML5 to the car. So, I mean, it's good to get rid of Java in the car, but if they should replace it with HTML, I'm not entirely sure. And if you have a look at Gmail, Gmail is huge. Some time ago, precisely on the 27th of January this year, I decided to have a look at how much JavaScript Gmail is actually using, and I measured it a little bit from opening the Gmail application and opening a single mail. There was like an amount of 3.5 megabytes of JavaScript. Like, who wants to debug that? Like, this is just like 3.5 megabytes of compressed JavaScript. That is not a small website anymore. This is like a huge and powerful operation system-like application that we're talking about. And this is capable of HTML and JavaScript and the DOM. There is a lot of research that has been going into defense, like how to defend against injection and scripting attacks. And there's a lot of layers that actually exist because of that. We have network-based defense layers. We have IDS systems, IPS systems, web application firewalls that never work. We have several server-side defense layers. We have mod security and other tools. We have client-side defense layers like the XSS filter in IE, the XSS filter in WebKit, Chrome, and Safari. We see CSP, we see NoScript as a Firefox extension that tries to protect the user. And one experience that we made in the past was basically we had a look at this, we bypassed it, they fixed it, we had another look at this, they bypassed it, they fixed it, and so on. So there is no silver bullet yet. There's a lot of documentation on how to defend properly against XSS attacks. Sometimes good, sometimes not so good. There's hundreds of papers, talks, blog posts, whatever. So I would say the Three Horsemen are covered quite well. Now you might ask yourself, who are the Three Horsemen? Well, it gets a bit biblical here. I discovered that the three horsemen of the apocalypse kind of resemble XSS, or the three kinds of XSS that usually is being talked about. We have reflected XSS, like the very simple thing, that pure thing that comes in via the URL or something else and is being reflected on the website and then executes JavaScript. Easy to understand, easy to prevent, it's just like purity. Then we have stored XSS, which is a bit more evil. It's like the red horse, same for war. It's harder to detect, harder to defend against. You need like a complex filter that is making sure that only good HTML can go through and the bad HTML goes out. And then finally we have the black horse, which is DOM XSS, disease, because it's extremely hard to defend against. And the only effective protection against DOM XSS is not to have DOM XSS. So, but what is a proper apocalypse without the actual fourth horseman? And we are today going to talk about the fourth horseman, the pale horse. And, well, enough with the kitsch. It's time to get technical. To talk about XSS and about a possible new way of XSSing web applications and other things, we first need to learn about the assumptions that are behind these attacks and behind the defense. So the first assumption is that reflected XSS, the white horse, it comes via URL parameters, via post, maybe sometimes via cookie, and we can detect this, and we can filter properly, and then we're fine. Then we have persistent XSS that comes in via post or via file or similar ways, and we can kind of separate the good content from the bad content if we want to allow HTML. We can kind of filter it properly, and we're going to be fine. And then we have DOM XSS that comes from DOM properties. Some of them are sinks, some of them are sources, and if they play along together and the user can influence them properly and the code is bad, then we have an XSS. So everything we have to do is just like make sure that these things and these sources are detected, are known, that the code is good, and that no DOM XSS happens. So it's a bit nasty, but we can still fix it by just making sure that the code is safe. And if you believe these three assumptions, and if we follow the derived rules from these assumptions, and if we, for example, handle uploads properly and set some security headers right for our web applications, we can effectively mitigate XSS. So it is possible to go ahead and say, like, hey, I create an application that is complex, and that has like a lot of rich text, but it can be free of XSS. That's possible, right? Yeah, we should believe so. Well, there is one hard thing, and the hard thing relates to persistent XSS and to the necessity of having complex filters. That is the telling apart, like the telling apart of the good markup from the bad markup. So how can we know what is harmless, and how can we know what is not harmless and can be used in a negative context? Good thing is we don't have to know, because we have advanced filter libraries. We have like the OWASP anti-SAMI project that is a good XSS filter. We have the OWASP XSS filter project that is even a bit better. We have the HTML purifier for PHP applications that is pretty damn good. We have Safe HTML from Microsoft. We have JSoup, which you shouldn't use because it's really crappy. There's many others out there, KSAS and so on, HTML also, those should not be used. And they're used in web mailers, in content management systems, in social networks, etc. They're basically everywhere. We see them in the intranet, in the extranet, in the www, messenger tools, and mail clients. And they are effectively the major gateway between fancy user-generated text on your website and a persistent XSS. If they don't work anymore, if there is like a global bypass in these libraries, then we have a problem, then shit breaks. So now the question is, we know that they are good. We know that they are thoroughly tested. And we want to think about how can we find a way as attackers to still get around the limitations that we have based on these complex HTML filters. Can we bypass them without even actually bypassing them? Can we trick them? Can we fool them? And can we find a little helper in the whole stack of displaying a website that aids us to do so? And, well, we can. But let's talk first about convenience. This lady has it all. She has like the perfect kitchen, the perfect oven, some white computer from some company with fruits. She has like a cell phone, and she's happy. Everything is perfect in her life. She has convenience. Like she doesn't have to worry about things. Like things are happy. And this is okay. People like convenience. And developers like convenience. And vendors like convenience. I like convenience. And some decades ago, Microsoft added a very convenient DOM property to the very fresh DOM back then. It started to become available in Internet Explorer 4, so it has been added quite some time ago. And it allowed us to manipulate the DOM without even manipulating the DOM and have the browser do the dirty work. Very, very, very useful. And this property was called inner HTML. So it allowed us to get direct access to the HTML content of a DOM element on our website. Read-write, of course. So we could read out the inner HTML and we could set new HTML and would immediately display on the website. And all the nasty stuff that is necessary was being done by the browser internally. So it was extremely convenient, especially if you compare it to the old way. So above here, you see the DOM way, which is lengthy. It's just like create an ID and then get an element and then grab another element, create an element, put it in there, append it, and so on. Like, nobody wants to do that. The inner HTML way, the convenient way, is just like grab this element, change the inner HTML, and be done with it. So this is what we want to do. This is nice. Well, the whole thing is easy. It's fast. Meanwhile, it's even faster than the classical DOM way, so there's benchmarks proving that inner HTML access is actually super fast. It's meanwhile a standard. We're going to talk about this later, and it just works. And it's even got a bigger brother, which is called outer HTML. I think I don't have to explain what this does. There's some contrast. It's a bit bitchy with tables because tables are special, especially in HTML. It's slow on older browsers, but nobody should use older browsers anyway. It doesn't really work in the world of XML because XML doesn't expose this kind of property. At least it shouldn't. Sometimes it does. And it's, of course, not as true as real DOM manipulation. Meanwhile, it's even implemented in every single browser. I don't even have to say meanwhile because it has been that way for ages. Because the other browser vendors realized that it's non-standard and not in the specs, but it's just such an awesome property that they decided to just rebuild the functionality and add it as well. So we can use it because it's fast, it's easy, and it's everywhere, and people are actually using it. We were collecting some numbers and trying to find out who's actually using inner HTML in their applications. And back then, the Google code search was still around. I really miss it. And I asked the Google code search, hey, Google code search, how many projects are actually using inner HTML or outer HTML? And Google code search said 184,000 projects, not files, projects. And that's a lot. And then I asked the newly invoked GitHub search and said, like, hey, GitHub search, how many GitHub projects are making use of inner HTML or outer HTML? And GitHub says, like, 1.2 million. So, oh, that's a lot. And I wanted to find out how many real-life websites actually use this, and wrote a small Alexa 10K parser, a crawler, and crawled the stuff and had a look at the index pages and at the JavaScript on the index pages. And it turns out that even just on the index page, without any login, 75% of websites use inner HTML. So people do use inner HTML, and it's actually quite good. One class of software that is kind of more or less existing because of this convenient way to use to influence the element's content are rich text editors, like complex monsters. Nobody wants to have them on their server or on their website, but sometimes we need them. And without inner HTML, creating a rich text editor would be just a major pain. But now it's quite easy to actually do so. And even they are everywhere, like in content management systems, web mailers, email clients, publishing tools, we can see rich text editors about everywhere. And now we might ask ourselves, what is the actual problem with that? So we have an awesome property, and this awesome property is awesome, and we want to use it. I want to use it right now. Like, give me some inner HTML. But there's got to be a problem with that, right? And the problem is when we have a closer look at what it actually does. So if we're naive and think about how it could work, then we might assume that inner HTML, or that something that I set by inner HTML, will result in the very same thing in the DOM. So if you, for example, go ahead and say, like, hey, I want your inner HTML to be foobar, then I expect that in the DOM there is actually the string foobar. But it gets more complicated if I add actual HTML to the inner HTML string, because then the browser has to do something internally and has to say, like, is this really valid? And if it's not, I should maybe make it valid, and then you should add it, and then you can have a look at it. So it doesn't really leave things as they are. So we cannot really rely on having our user input stay the same when it arrives in the DOM. And after reading it out again, it might even have changed a bit more. Well, it is the way, and it is the case, and it's not even bad. It's actually quite good, because users tend to submit invalid stuff, and the browser fixes it for them, and then everything's fine, and we have a sane DOM, and nothing is broken on the website. So we don't want illegal markup in our sane DOM tree. I wanted to find out more about this, and I wanted to find out how many variations do browsers actually commit before adding the DOM nodes that are incoming from inner HTML to the actual DOM tree. And are these changes in a way dangerous? So we created a little test suite, and this test suite is out there, it's available, and it shows us basically what inner HTML really does. Let me just show you the tool. Here, for example, we have IE8. And we have the tool. You can find it in html5sec.org/innerhtml. That's basically it, and it's going to stay there. And I have a text area here, and I can write stuff into this text area, and it's going to be displayed here, and it's going to be mapped via inner HTML to that element's content. And afterwards, I read it out again and put the result into this text area. So let me just show you how it works. I can say, for example, an S element, and then the whole thing is struck. So we map this piece of markup to the content of this element, and afterwards we read it out again and show the result in the text area. And we can see that something is strange here, right? Can you see this in the last row? Is this big enough, or should I zoom it in a bit? Is it fine? All right, great. So here I have an opening S element, and then the string hello. And the text is actually struck. That is what we expect. But the result, what the browser does with it internally, is different, because we have an uppercase S, and we have a closing element. Here we were sloppy. We didn't add this closing element. But here we have the closing element. So we see the browser does two things. First of all, the browser says like, lowercase s, I don't know HTML5 yet, but I do know HTML4, and this is per default all element names in uppercase. So I'm just going to uppercase it for you. And wait a second, developer, you were a lazy bastard, so you just omitted the closing element. So I'm just going to add it for you. That's how awesome I am. So that's cool. Thanks, IE. I actually like that. That is nice. Thank you, IE. And this is actually being done by every browser. It's not just being done by IE. Browsers have to do this. They have to fix what's coming in. I can even go ahead and, for example, just like nest a bit more and say like a div element here and then a p element here. And you can see all these things are added automatically. Here's a div, here's the s, the p, and so on. Thank you, browser. So, there is interesting stuff when you have a look at more detailed things in HTML. So one of the very simple things in HTML are comments. Like everybody should be knowing how HTML comments work. You start a comment, stuff is commented, you end the comment, stuff is not commented anymore. That's easy, right? So let's have a look what the browser does internally with comments, because it's a bit different. Let's have a look at Firefox, for example. We go ahead and we select, all right, we have like an element here, and then just add a comment here, and wait a second, that was fast. So we just have the opening lesser than here, and we have the exclamation mark, but the browser says like, hey, I kind of think that you want to do a comment, so I'm just going to do it for you and just going to give you that monster here. It's like, all right, fair enough. So I just finish it and make my real comment. So like, okay, browser doesn't change anything. So now we have a comment. Now we have exactly what we expect. If we remove this, the browser says like, yeah, but you're not closing it, so I'm closing it for you. All right, interesting. We can remove this, and the browser says, yeah, I kind of expect 2 minuses, 2 dashes, so I'm just going to add it for you. So, all right, it's going a bit far, like not so stormy. We remove this, and the browser will still add this because the browser says like, yeah, you didn't close the comment, so I'm going to close it for you, and so on. And it gets more interesting when we remove this thing, and for example say, let's do it like this. So now we comment the dash, right? So we have 2 here and 2 here, and in the middle we comment out the dash. So that's fair. Now when we remove this thing, you will see that upstairs we have 5 dashes, downstairs we have 4. Now we remove from more. Now we have 3 upstairs and 4 downstairs. What? And then we remove from more. Then we have 2 upstairs and 4 downstairs. What is going on here? We remove 1 more, and that's growing to 5. And then we remove 1 more, and it's staying again at 4. It's like, what? That even makes sense. Like, that even makes perfect sense when you have a look at this, because this is kind of a valid comment, but to make it a valid comment for the browser, for the actual engine, the browser has to add the dashes. So this being an empty comment will be turned into this, which is minus minus and minus minus, so that makes sense. But once I add, for example, another dash, the browser isn't really sure if I want to comment out that dash or if the dash is part of the comment, so it better adds the full comment and then comments the dash, so we need 5, and so on. And if you think about it, it does make sense. It's crazy, but it does make sense. Well, at least this crazy feature is consistently implemented, unless you have a look at older browsers, but you can see there's crazy stuff happening in here, and it gets crazier. And now we have to ask ourselves, what does the whole thing have to do with security? Because we're a security conference here, right? So is there any security impact of this whole thing? Well, there is. In 2006, in Japan, a fellow desk worker was working on a document and wrote some HTML. And finished his document and had some beautiful tables on there and forms, and they had values, and it was awesome. And he said, like, that is a beautiful document. I'm just going to send it to the printer and just going to do something with it afterwards because I like it so much. And he sent it to the printer, it printed, and he went to the printer and took it out. And said, what in God's name is going on? And he realized that there was a bug. So the document didn't look the same. It's like, God damn it, I'm going to print it again. He printed it again, and it was the same thing. And he got crazy, or he got mad because he realized that he had no idea what was going on. The content of the form elements, of the input elements, were no part of the document. They were bleeding out the elements, and the elements were empty. So he was like, how is that even possible? And at some point he gave up, and I think he filed a bug report, and no one listened, and that was that. Well, not exactly. 1 year later, a researcher from Japan, Yoshiko Ashigawa, analyzed the problem and found out that this is a really, really bad problem. And he found the first pointer to what we want to call the fourth horseman, or MXSS, mutation XSS. And I want to show you what he found. And I want to make sure that you know that this problem existed until mid this year. So it was fixed mid this year, mid 2013. So we have been living with this thing for, I don't know, almost 6 years. So let's have a look. Again, we take our favorite browser, IE8, and we say like, hey, IE. So we're going to give you some HTML again. Let's just, for example, we give you an image. And we can see here's our image. And there's the rest of the image below. Everything's fine. I'm just going to zoom it a little bit because we're going to use a lot of strange characters. And the cool thing with HTML is you don't only have tags, you also have attributes. Like, how awesome are attributes? We can go ahead and say, for example, let's get it in a source and point it to somewhere. And then we want to give it a class. And we have an empty class because we haven't decided yet on how we're going to call it. And we realize that if we give that element an empty class, the browser says like, empty class doesn't do anything, it's so expensive, I'm just going to strip it out and send it to the layout engineering afterwards. Like, okay, you strip out the whole attribute for us just because it's empty? That's a bit, I don't know. But browsers do that. And then we go ahead like, okay, but if we give it an actual class, then the browser can't strip the element anymore. So something has to happen. So we'd say like class A. And all of a sudden, the class appears. The browser says, oh, no, you get a class, and I'm just going to show it here. Now, what is special with this class? What is special with the internal handling of the browser? Who sees it? There's something very special. You know it already. You don't have to raise your arm. That's unfair. Like, yes, the quotes are missing. So the browser says, like, quotes are expensive. Just going to leave them away. And that's not a good thing. So we might assume we're using quotes here, we're nice developers, but the browser strips the quotes because they cost too much money. Do we have an injection by just adding a space? And we can try this. And no. The browser realizes, hey, I know what you're doing here, you're adding a space, you want to inject something. I'm just going to add those quotes again. And we said, all right, fair enough. Sorry, browser, fair enough. Remove the space, quotes disappear again. It's like, why not single quote? Right. Again, the browser realizes single quote doesn't work at all, so we don't have something really bad here. So there's damn it. But little of us usually know that there is 4 ways of delimiting attribute values in IE. So in HTML, there's 3. No delimiters at all, double quotes, single quotes. In IE, there's 4. What's the 4th one? Right, the backtick, excellent. So we can use the backtick to delimit attribute values. So if we go ahead and, for example, try putting a backtick in here, doing like this, then we have 2 backticks, and we realize that the backticks are not being quoted. So now we have an empty class inside a class that is originally supposed to be called backtick. And that means, goddamn, we have an injection. So we can, for example, go ahead and say, on error equals alert 1, and there is just this, and then this. And then it probably takes some time. Did I mistype? Oh, I'm an idiot. No, it works. It was 1 space too much. So now we have an injection. And the special thing with this injection is that it's completely valid, completely sane markup. Every XSS filter will say, that's cool, I don't see anything bad in here. You have a class, it's properly quoted, no one breaks out. You can put whatever content into the class, I can deal with that. But the browser, upon accessing the inner HTML property of that thing and doing something with it, will remove the double quotes and all of a sudden will become an XSS. Like out of nothing. Every XSS filter out there, every single one, let this through. Every single one. We tested every single one. And none of them object and said, I can kind of see that there's something bad in here. And this problem was existing for 6.5 years. So for 6.5 years, every second web application out there was vulnerable without even knowing it, just by using this trick. And, well, this is kind of how people usually react when you tell them about this, just as a reference. It's pretty bad, but it's not new. I mean, it's been around since 2006, just not really been exploited. And it doesn't even work anymore because it was patched some weeks ago. So, like I said, mid of the year it was actually patched. It doesn't exist anymore. So even in IE8, the problem is not existing anymore. So it's not new. It's just not new. We like it, and we can use it to see what MXSS is and what the whole thing is about. It's about mutations and doing stuff internally, or have the browser do stuff for us as attackers. But it's not new. The good thing is we have new, because there's more. There's significantly more. So A browser faces an interesting challenge when dealing with unknown elements. So with HTML, you have a namespace, and so like these elements are in there, like all the headlines and links and whatnot. But if there's an element that is not known, that is not in a known namespace, then the browser has to think, like, what am I going to do? What am I going to do with that? And let's have a look at this. We got an example can go ahead and say like, we create an element that we call X, and then we say 1, 2, 3. And we're like, okay, we have an element here, but the browser just omits it. Well, fair enough. Let's just close it. And wait a second, we close the thing, and only the closing one is there, the other one is gone? That is a bit fishy. We have to have a look at that. And then we say like, okay, if we put some content here and use, for example, a 0, then all of a sudden the X reappears because the browser says like, yeah, you have content in front of the new element, in front of the unknown element, so I better gonna render it somehow. And I don't see the logic behind this. But the browser does this. But we can see that dealing with unknown elements is kind of a weird thing. Like browsers have trouble doing so. So you can also see that it's, for example, now it's uppercasing, before it wasn't, and so on. And another question is, if we want to tell the browser what to do with the unknown element, then we have like one traditional way to do so, and that is using a namespace declaration. We can just go ahead and say like, hey, element, we're just going to give you a little namespace, and then the browser is probably going to know what to do with your old friend. And so we give it a namespace, so like XML and S equals empty. And unlike class, an empty namespace declaration is not being omitted. So we do know from just looking at this small detail that we're in a completely, entirely different execution branch inside the browser internals. Another interesting question is, what would happen if I give that namespace actual content? So let's just, for example, say we come up with the namespace X. All of a sudden, IE entirely freaks out and says like, oh, I'm just gonna do something very, very crazy. Just don't judge me. And we can see that there is like a processing instruction, and it's getting like a namespace as an element name. It's not really clear what this kind of construct is. Then there is like a prefix attribute. Then there's a space coming from nowhere, equal space, and then something delimited by rectangular brackets, and then we have something here, and just what in Christ's name is that? But we realize that the content of our namespace attribute is actually reflected without quotes. It's right here. So again, we have an injection, do we? Let's close the whole thing, open a new element, say ing src equals, and the error equals alert, and the one, and there we go. This is also not so good. This is pretty shitty, actually, because this shouldn't happen. Again, we have an attribute that is properly quoted, no one breaks out, but still we have an injection after the browser is receiving the markup and working with it. That's pretty bad. It's actually not that bad. It is bad, but not super bad, because most XSS filters do not allow namespace attributes, and we require this namespace attribute. Also, it's not mine. This was discovered by Level 1 from Russia, but we found an interesting variation, because we actually do have bad, and at least a bit worse than that. Let me show you. First, we're going to get rid of these alerts. So here we've been nice. We've been closing the element. You can see it's closed. Here's the closing X. Here's the opening thing. Here's the namespace. Everything's properly quoted. And we get this kind of weird thing here. What would happen if we're naughty and we don't close the element? We just remove this because we're lazy or naughty or just want to play around. Interestingly, this kind of weird namespace explosion does not happen if we don't close the element. So again, we're in a different execution branch. Like, how many are there? And we asked ourselves, okay, nothing happens, there's nothing special here, but wait a second, there was an alternative way of declaring namespaces. We have this kind of URN notation, right? The one with the colons. And we go ahead and say, for example, if I add a colon here, and then, wait a second, I have a colon here, and then the colon is there? Like, how did it go there? Like, how did it travel there? And then I was like, that's kind of strange. Let me just say img, then what? Now we have an img namespace, and we are just like one space away from another injection, right? But you can't use spaces in namespaces. Like, come on, I think it's in the stone-written rules of XML that a namespace cannot contain space characters. So let's just try it out. Whoops, in IE, that's not the case. IE accepts spaces and namespaces and creates an image element for us. So can you see this? No image? And we have an image. There it is. So that means we just go ahead, say source equals X, and you know it already what's going to happen. So on error equals alert, and then we close the whole thing. And then we have to actually be a bit nicer here. And there we go. and another injection, like another injection that doesn't violate the markup structure, and another injection that is most likely to slip through XSS filters, if it wasn't for the stupid namespace. But I think we all understand now a bit more on how these kind of attacks work, and well, that wasn't really bad. It was pretty bad, but not too bad. Like I said, only one was new. The other one was pre-discovered by level 1. And this is the other one. Like I said, it's few websites actually allow XML and S, and it only works in certain document modes. You can force, for example, IE8 to accept HTML5, and then it's being treated as an unknown element, and you can do these things with that. But you need the XML and S. So it's not entirely bad. But we have bad. We actually have really bad. So we decided to have a closer look at this whole thing because it started to get crazy, and we started to find more and more variations and more attack techniques that are completely different but accomplish the same thing, which is an injection inside valid and sane and benign markup. So everybody loves style attributes, right? That was such a great idea with the style attributes, like mixing together HTML and CSS in an attribute, like 2 different languages. That was a great idea. That always works out well. So it's just CSS, and we cannot do that much with style attributes unless we, for example, use CSS expressions and all these common and known techniques to do bad stuff with CSS. Every well-trained XSS filter will know that these kind of things have to be stripped out or have to cause an alert so they're not working anymore. Well, we need to have a look at our test suite again because there's something crazy with CSS. Let's use a slightly more modern browser and have a look at them style attributes. So we go for example ahead and say we create a p element, and we give the p element a style, and we say whoopsie daisy, say color is expected to be red, and then we write something in here, say 1, 2, 3, 4, 5, 6, and then we see, all right, the color is red. This is what we kind of expect. There are some changes. There's like a small mutation here, like a space here, and it's adding the semicolon for us that we forgot because we're lazy. But in the end, there's nothing unexpected here. So now let me go to the to a slightly different document mode. Again, see, we know in an old document mode that you can trigger from the outside. Now it's uppercase, but there's again the space and so on. It's nothing super special here. But we also can use strings in CSS. We can go ahead, for example, and can say font family, and then we can say foobar. And then we can realize, foobar, it's not that complex. Let's just go ahead and quote this thing. Now there is an interesting thing. If you, for example, have a font designer in your company, and this font designer is a Scotsman, and he wants to create a font that is called O'Malley's Bar, then he needs a single quote in the font name. People do that. So if you want to, for example, express a single quote in the font name, then you would, of course, just destroy this thing. Like, this doesn't make any sense. So you have to escape it. And the way to actually escape this thing is using CSS escapes, big surprise. And the CSS escape for the single quote would look like this, \27. So perfectly fine here. That is exactly what the XSS filter accepts and says, oh, that's cool, everything fine here. But upon accessing the inner HTML property, you can see that the browser is decoding the escape, that the escape is now being shown in the canonical representation. So the escape doesn't escape at all once you access the inner HTML property. So what you can do is move on from this and, for example, say 3b, and then you can say x, and then you say equals, and then you say expression. And I'm tempted not to do the alert right now because then there's going to be a loop. I'm just going to inject some JavaScript that is changing the location. So if you see it change here and it changes to 1 or 2, then you see that the script is executing, all right? So we go location dot hash equals 1, and then we close the whole thing. We can even use escapes here. And what is missing? Oh, yeah, there, of course, yeah, there's a space missing. There we go here. And you can see, whoop, it changed to 1. So we have JavaScript execution, we have a full XSS. It's not as spectacular as the major alert, but you can see we execute JavaScript. With the construct, again, where nothing is broken. We have the single quote here, we have the single quote there. We didn't break anything, that is benign, but the browser weaponized it for us and renders this monstrosity here. And that is really, really bad. And there's like an extremely weird feature that IE uses to handle something internally that allows us even to use the escape for the double quote to actually create the single quote. So if you use the 22, it will still become a single quote. So even if you go ahead and on the server-side filter and decode all this thing and then have a look if it's proper or not, this will also go through. So you can see here, we create the single quote from the entity of a double quote. So let me just make it into a 2 so you can see there's actually code execution here. Oh no, the browser crashes. Oh no, please not. No, there we go. And here's the 2. So that is pretty bad. That is actually very, very bad. And the big problem with this is that up until recently, when we reported these things to most of the vendors and filter manufacturers, that everything was kind of attackable by this. And there is another problem. The problem is that there is like so many variations for this. This is just one thing. And we had a golden rule back then when we discovered this thing and said like, hey, customers, hey, vendors, do not allow escapes in your user-generated CSS because then you have a problem. Best, do not allow backslashes at all. So we recommended that, and then we realized that we were wrong and that there is like possibilities you can do this entirely without backslashes. Please don't crash on me. I'm just going to restart. Where is it? All right. And there we go. So one very interesting variation that I want to show is we go ahead and say p-style equals blah, 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 font family, and we say foo bar and bar foo. So now we have a font that has the name foo bar bar foo, which is not the nice name. Like you shouldn't call things bar foo. But the interesting thing is we again have it quoted, and we want to break out these quotes without using backslashes, without using escapes. So there is one feature that allows us in CSS to chain multiple fonts in a font family declaration that says like, hey, if this one font isn't there, use the next one. If this one isn't there, use the next one, and so on, like to provide a fallback. And these kind of fallbacks are delimited via a comma, but they only are supposed to work if they are not quoted by strings, because the comma shouldn't be stronger than the string. Now let's have a look what happens if we add the comma. The second we add the comma, the quotes disappear, because IE thinks like, hey, yeah, you have a string, that's cool, but I kind of think that you want to concatenate some font names as a fallback, so I'm just going to remove those, those single quotes for you. Is that all right? No, that's not all right. That's really bad, because we have another injection, because then, of course, we just have to close this whole thing and go like x equals expression and so on, and again, we execute JavaScript. And there's even one more thing that is even worse, and we discovered that there is a property that does something extremely unexpected, and that is border, what was it? Border spacing, I think. Border spacing. And we go here and select foo. And we take border spacing, which looks so benign and so harmless, and we give it a value that is properly quoted, and it just leaves it away. It just omits the quotes, just so. We don't have to do anything. We don't have to use a special character or some sort. It just disappears. And there is one more variation that I want to show you, which is really, really crazy, because we learned that we can break CSS strings with using escapes, with using a comma, and with using weird properties that are not supposed to do this thing. But can we also break the markup? Can we break the entire HTML by using these things? And actually, yes, we can. So if we would want to break the HTML here, we would go and, for example, try to use a double quote, hoping that this double quote would be able to break these double quotes. But as we learned already, IE transforms those double quotes into single quotes, maybe for even that exact purpose. But we so far only tried this thing in attribute values. We never tried this in attribute names. So what if we go here and just say like, all right, double quote, or maybe I shouldn't use it behind the D, double quote. Then all of a sudden we have a real double quote. So we just ended the style attribute with a CSS escape inside a property name. Like, what the hell? So we can go from here and, for example, say, all right, let me just close the whole thing and create some new element. And then it's like, oh, no, can't do this. That's weird. So we go ahead and I'm going to 3E. Oh, no, it works. And then we select 3C, IMG. And then we need like the space, source equals. Oh, no, the equals is semantically important, syntactically important for CSS. So we can use it again. 3D, and then we say about X, and then the space again, and then on. As 3D, and then we need to use the 6.1 alert and 28, and then the space. Oh no, can use the space. And we can just make standard alert, and then we close the whole thing with 3E, and there we go. So that's not good, and that shouldn't happen. And that is still there, it's not fixed yet. I think there's a fix number, but that's not fixed yet. So if you have user-generated CSS in your website, and if you allow user-generated CSS, make sure that these things can never happen. Make sure that the property names are being validated, that certain amounts of characters cannot exist, and there are commas, backslashes, and so on. Better just don't do it. Well, there is other problems that we found problems with HTML entities. So, for example, Chrome recently messed up with text area, found and reported by Eduardo Vela. Firefox majorly screwed up with SVG in 2011. They fixed it immediately, and this kind of thing was possible. So inside a style element, you can use an entity that would automatically transform into the lesser than and then execute the code. In IE, you can use listing because everything inside listing is auto-decoded, and everything that, for example, you're using in the world of text XHTML, if you want to avoid HTML and use XHTML, is auto-encoding many things in many constellations. So everything that is C data is basically being auto-decoded. This applies as well for inline SVG and for MathML, so try to get away from inline SVG and MathML if you can, because it's not a good thing, it's not mature yet. Now the question is, who's affected? Actually, back then when we did this research, most existing HTML filters and sanitizers were affected, even the real good ones. HTML Purifier, JSoup, Anti-Semi, HTML Lot, Google Kaha, whatever, so they were all affected. All tested rich text editors were affected. Most existing webmailers were affected. Is anyone using Yahoo Mail? Because they were affected. Roundcube, other solutions, all these tools were affected. And we can kind of create a rule and say, like, basically anything was affected that obeyed the standards, that followed the standards, because the standard says, hey, do it like this, but the browser said, no, we do it differently, do it like that. And this kind of gap between the standard and the browser implementation actually caused the vulnerability, so, which is quite bad. Here's a screenshot of HTML Purifier who was affected back then. Here's a screenshot of Google Kaha and the version that was affected back then, so you can see the stuff is coming through. Here the expressions are coming through. Here's a screenshot of HTML Lot that was affected, and I'm pretty sure that it's not readable in the last row. What we can see here is HTML Lot actually went a step further and almost killed our bug because they double encoded stuff, and it looked like this, like ampersand and then the entity for the whole thing. So it was an escape that was encoded and then encoded again, so actually like triple encoded. And we asked ourselves, like, is this a problem? Does that fix the bug? And of course not, because the mutations, the MXSS, so the transformation from an encoded to a decoded state, works recursively. Just access inner HTML twice, and then it will decode twice. So if you have triple encoding, just do it 3 times. If you have quadruple encoding, do it 4 times. So there is no real limitation for the attacker here, for your health. This is usually the reaction if you show this to developers. I showed this presentation on a developer conference, and then I had to run. Now the question is, how do you protect against these kinds of attacks? As a fancy website that is modern and flexible and has a good framework, just make sure that standards mode is enforced for your browser. Avoid getting framed, use cross-frame options. Make sure that you use this doc type and no other doc type. Don't use the old HTML4 doc types, because they kind of enable this attack via framing attacks. Use this one or no one. No, just use this one, don't use no one. Use CSP if you can, not everybody can. Motivate your users to upgrade their browsers, and like nothing else, avoid SVG and MathML because they also enable these kinds of attacks. Actual websites that really have a bit more costful maintenance routines, patch your filters. Employ strict whitelist, do whatever you can do. Avoid critical attributes and critical characters in user input. Be extremely paranoid about CSS because CSS is going to screw you over. Don't follow the standards because the standards may be right, but the browsers are wrong, so follow the vulnerabilities and kind of fix the bugs on your own, and know the vulnerabilities, and that is what we, I think, just did here. For a pen tester, when you find a website where you can inject style attributes, backslashes, or ampersands, you already won. Like, you have an XSS, so you can just go home and say, like, oh, well done, we have a free bug here. And if nothing goes, use the backtick trick. I mean, it's not really available anymore, but it's kind of a bug. So, we had a look at alternatives for fixing these things. Like, we were thinking about how you can actually fix this in the client. And I wrote a small script that can actually do this. I call it True HTML. It's basically released under the whatever the fuck you want to do with it license, so you can just grab it and it's here. I'm not going to show the demo because we don't have enough time, but it intercepts the access to inner HTML and applies an XML serializer-based sanitization of the input. So it sounds slow, and it is slow, but not too slow, so it's mainly an experiment to see how far we can go in the client with fixing these kinds of bugs and attacks. Well, bottom line is, know your C data sections, make sure that you know about these characters. Try to avoid SVG wherever possible, because this is like really extending the attack surface. Inline SVG is absolutely the devil. And the same with the MathML, which is extremely complicated to implement. I mean, Chrome just took MathML outside the browser before the pound to on because they knew they would be pound with this thing. So, takeaway, we almost reached the end of the presentation. What was in it for you? As a pen tester, you just got a free new wildcard bug pattern. You will find these things in the wild, definitely. We find them all the time. As a developer, you have better info or new info to actually protect your app from input that you didn't know was malicious at all. As a browser vendor, you live at a pointer for an exciting problem zone to watch. It's like, don't do these things internally. I mean, there has to be manipulations and mutations, but don't screw them up. And for the specifiers, there's actually some practical hints for the upcoming specs. And the good thing is, there is going to be an upcoming spec because the W3C took over inner HTML, and now there is like an inner HTML specification that is covering all these issues. So there might actually be like, like a silver line on the horizon where we can actually say like, hey, something good is happening in the world of specifications. And maybe at some point we can actually follow the specs again. Wrapping it up, today we saw some interesting HTML DOM and browser history, some known attacks that we revisited, some unknown attacks that we saw for the first time, a perfect pentest joker, like something that gives you a free persistent XSS and everything that accepts HTML, some guidelines on how to defend against these attacks, and a kind of sneak preview for the W3C silver bullet that maybe 2015 is usable or maybe not. We will find out about that soon. So that's it. If you have any questions, just address them now or later. You can catch me offline, and if you have any comments, give them to me. Credit where credit is due. This was not solely my research, so thanks to Gareth Hayes, Yushuki Ashigawa, Level 1 from Russia, Eduardo Vela of Google, David Ross from Microsoft, who actually permitted me to do this talk and to release the paper, and Stefano Di Paola, who helped as well. So thanks to those guys. And thanks to you. Bye. Any questions? There is a question, I think.
Yeah, so you described a very neat vectors for triggering XSS via inner insecure, let's say, inner HTML person. But is there any way to actually force the web application that has user-generated content somehow filtered server-side or in JavaScript to actually call the inner HTML? You mentioned the print preview.
Yes, that is exactly the case. So the print, for example, is one thing where you can do this. Is
it all over the browser vendors? Do they use inner HTML?
I can't go into too much detail, but not anymore. There is other ways you could do this, and there is still some ways left you can do this. One thing is, for example, design mode. But you have like a constraint that you have to have Java installed, so you can only mutate an applet into this thing, because otherwise the JavaScript would not execute, so you need to Java an applet via the mutation and so on. But there is ways to trigger it, but it's complicated. So the most prominent ways are actually user-generated HTML via HTML emails or chat messages or whatever is coming in. So
thanks.
We didn't find like an atomic bomb that allows us to mutate XSS every single website out there by doing something from the outside. We tried to, but we didn't. We came close with this design mode thing, but we didn't actually manage to do so. Maybe someone else finds something, so can't be excluded. But yeah. Any other questions? There is one.
For you, is mutation XSS a new category of XSS, or is it a subcategory of DOM XSS?
I wouldn't necessarily call it DOM XSS because it doesn't come from the classic sources and things, and it relies on something to happen that all the other techniques don't need, and it uses benign markup. So I would go as far and call it a new XSS, but one might disagree with that. But I personally think it's a new XSS. Any more questions? Nope. If you have further questions, just catch me later on with a beer and it should be fine. All right. Thank you very much.